Sorry about that, guys. I'm using an unregistered version of Bandicam. It only allows 10-minute videos to be recorded. Didn't realise I'd been talking for so long. Also, I don't have video editing software, so I won't be able to cut out the point where it drops off. But anyway, I'll just get right back into what I was talking about. I was covering the plasma cannon at the time, and I'll just go over what I mentioned. So over here we've got the X, the attack and release will 100, that means it gives it out of binary data points. So it's 1, hold X, it gives out 1. The toggle is the thing that makes it change between on and off instead of constantly flickering. You'll see the values here, 0 and 0.5. The reason for the 0.5, like 0, obviously that's when it's off. 0.5 is because it's going into an oscillator. This oscillator is using a square, which means it will only go between the minimum and maximum points. Just switch between them as is appropriate for the wave it's attempting to create. It's basically, so it is a square wave. If you know anything about how like waveforms work, you should have a basic understanding. I'm pretty sure if you just Wikipedia that, it might come up with a decent article. But anyway, what happens here, we've also got an offset and an amplitude that both link to the toggle sample. The offset is how high you want the midpoint to be. Right, so by default it's 0, and at the moment it's set to 0. That's not overly complex. The amplitude is how high above and below that offset you want it to go. So at 0 it does nothing, but when I turn it on to 0.5, you would have noticed that the sample was flickering between 0 and 1. This is because offset 0.5 is the midpoint, and the amplitude 0.5 puts it up to 1 and down to 0. See, 0.5 on either side. The square, type square, as I said, makes sure that it only touches maximum and minimum. The frequency is the number of times per second that it oscillates. 8 times per second, that just seemed optimal for this particular arrangement with the 2 flux capacitors. What happens is this is output into here, sample, which is put over here, and then which is put from here over into both capacitors, basically telling it to charge every capacitor, and into the selector of this toggle, which makes it swap between the 2 flux capacitors, which basically causes it to alternate between firing of one and then the other. Now, the reason for this is, I believe there's a maximum rate in which you can charge a flux capacitor. So more flux capacitor means faster firing, potentially faster firing cannon if you set it up properly. And then obviously I output the flux capacitor into the energy source of the plasma cannon. So what's happening is these 2 flux capacitors are alternating between which one is powering the cannon, which one's not, and the cannon is just sitting there firing as fast as it can. It also gets an output from the oscillator. So the oscillator's charging the flux capacitors, causing the cannon to fire, and telling the cannon to swap to a different flux capacitor every single time. It oscillates to 1, which is of course 8 times per second, which means it fires. So this setup will fire 8 shots per second. Now, to improve this, I would like to add flux capacitors, 2 more flux capacitors, one on the front, one on the back, and move where the camera is connected to, because obviously the camera at the moment is voltaically connected to the hover on the front. I'd probably just move that voltaically connected to the top here, because voltaic connections aren't solid, so it won't cause any problems. Or shouldn't cause any problems, at least. If I was to do this, I would have to up the frequency here to 16. Twice as many, like 4 per thing, but this toggle would not be enough. Toggle only goes between two inputs and outputs. I would probably use I'd probably use a counter. I'd have to create a counter using logic gates. As you probably noticed, there's a lot of, this is entirely binary data. I don't think there's any point in this particular code in which it uses analog data, and it would just have to count. Right, so go 0, 1, 2, 3, 0, 1, 2, 3, and then that would just change which of the parts it uses. I have an idea how to implement that. Yeah, if you wanted to implement something like that, I would suggest searching logic gate counter to Google. It should give you a decent overview. The logic gates, of course, are literally just a command. Like, you can just see logic gate, you just add it, and then it allows you to have the various types of logic gates. There's nothing too exciting that you would need to make a counter, I don't think it would be particularly hard, but of course, eventually I will put up a tutorial on how to make it to make this cannon fire faster. And that's pretty much it for this particular bot. There's nothing really exciting. However, I will show you guys. It will be added to my part compendium when I eventually get around to it. Part compendium will be, I'll link in the description, but it's on the Rawbot forums. It's not too hard to find. I'm just showing you that I found something that's in the lab that I have not seen before on Gaia. So if you guys want to experiment with it, feel free. I have not yet done so. It's this part here called the hypercube. I assume it works like a hyperfield, except firing only out of one edge. If that's true, that thing will be really cool once people start experimenting with it. But the only way to find it is to get up on the top of this cliff, tower thing. So you might want to think about making a flying drone if you want to experiment with that. Anyway, that's it for me today. I'll see you next time.